So hopefully you took the time and worked through the calculations again, just to give you some practice, understanding and anchoring in your brain the percent change formula and figuring out how to do this. Now, the values I got here, I'll just put them in. Again, the cumulative inflation from 1913 to 2007 seems almost too large to grasp. However, across this time period, if we had had that average growth rate of 3.9% in the price level, we would have seen, right, a cumulative growth rate of 3,546%. So that's not uncommon, right? Remember, the small changes in growth rates yield large aggregate changes across long time periods. So in other words, let me rephrase that. Small changes or relatively small levels of annual growth can lead to massive changes across long periods of time. Hopefully that's something you're going to take away from this class and this semester. So again, if we go back all the way to chapter 5, or when we were talking about GDP, we had this idea that to compare production in 1990 with production in 2010, we could measure 1990 production with 2010 prices and compare it with 2010 production measured in 2010 prices. Or we could measure 2010 production with 1990 prices and compare it with 1990 production in 1990 prices. And again, the whole point here, as we do this, would be to take out the fluctuating value of the dollar. A dollar in 2000 is not the same as a dollar in 1950. This is analogous to the fact that when I go to the doctor's office, we're used to the idea that a pound, when they weigh me, a pound in 2020 is the same as a pound in 2000. And so we don't have to convert 2020 pounds into 2000 pounds. In other words, what we're dealing with is constant pounds. The issue, of course, here is that we're not. Dollars, a standard of measurement here, fluctuate. The purchasing power of a dollar, we're not talking about the exchange value, we're talking about the purchasing power of a dollar, changes from year to year. And so what we are in effect doing is having to measure things in a constant unit of measurement. And I think we understand that if we didn't do that with everything else, if we didn't do that with kilometers or miles or pounds or inches, that we would have to convert into, if we were comparing my weight in 2000 with my weight in 2020, we would either need to convert my 2000 weight into 2020 pounds and compare it with my 2020 weight in 2020 pounds, or we would need to convert my 2020 pounds into my 2020 weight into 2000 pounds and then compare that with my 2000 weight in 2000 pounds. As you can tell, the English language is not fully set up for, and we are not used to describing things in these terms. And so it sounds confusing, but in effect, it's just saying we have to convert things into a constant unit of measurement. Now, we could also, incidentally, and if we were looking at pounds changed between 2000 and 2020, we could convert both 2000 and 2020 pounds into 2010 pounds. It doesn't matter what year's pounds we convert to as long as we are using the same standard of measurement. So this is something that's practical. It's something that we almost certainly need to be doing because, again, if you don't do this, if you aren't looking at constant dollars or real dollars, then the issue is going to be you are going to be mistaking a change in the price level for a change in your income or a change in your expenditure. And so this formula is an important formula, and it's a practical one. Now, I would say you probably want to remember this formula, not just for this class, but beyond this class, because there are many online inflation calculators. But it's actually fairly difficult to get somebody to explain the formula that is used to you. I suspect this formula is going to cause a little bit of frustration for some of you, and so we're going to need to actually practice some of it to see if we understand it or not. The way it's going to work is you are going to put the price level for the year's dollars into which you are converting as the PX. In other words, this is the price level in your reference year, in your base year. Now I'll make a note. This price level, P sub X, does not have anything to do with the base year that is used for your index. You can use any year here. So that's one source of confusion that we can do away with. So if you were converting to $1960, you would put for P sub X, what you would put in there would be the price level in 1960. If you're converting into $2020, you would put the price level in 2020 in for P sub X. And that's going to be the same for every year's prices. You're going to put your year's dollars into which you're converting in for P sub X. And then what you're going to do is you're going to put the nominal price, just the price of the good in a given year's dollars, in for the nominal sub I. And then you're going to multiply nominal sub I times P sub X, that's our price level in the base year, or the year into which we're converting, divided by the price level in the year that you are using. So in this case, say we were converting the price of a 1960 Chevrolet into $2020. That would give us the price of a 1960 Chevrolet denominated in $1920. That would be the real sub I X. In other words, X is the year's dollars into which we're converting, and I is the year where the price is collected. So we would take the price of a Chevrolet in 1960, that would be nominal sub I, times the price level in 2020 divided by the price level in 1960. If we then want to compare that with the price of a Chevrolet in 1970, we would take the price of that Chevrolet in 1970, that would be our nominal sub I, times the price level in 2020, divided by the price level in 1970. And we would do these to make a fair comparison. This is what we would do. We would take all of our nominal prices times the price level in 2020 divided by the price level in the year in which the figures were collected. And what that will do will be to give us the price of a 1960 Chevrolet in 2020 prices and the price of a 1970 Chevrolet in 2020 dollars or 2020 prices. Really, it should be in 2020 dollars. Again, what we're doing is this is analogous to the value of a pound changing across periods of time. We could do the exact same conversion with pounds. We could do the exact same conversion with inches. And while this may seem somewhat far-fetched, that actually has to be done with historical data because the definition of a pound was not fixed until the modern era. It's what we call the standardization of weights and measures. And you want to talk about an area where there probably are significant spillovers to having standardized weights and measures, and where there might be a role for collective action. I would say that that is a clear case where there would be a role for collective action or government. So that's how you calculate nominal to real. So let's try some examples here. Now, if we were in class, I would divide the class up and say, you on the left convert all of the price of gas. So this, what we have here is the price of gas, a gallon of gasoline in 1982, and the price of a gallon of gasoline in 2006. Now, what this looks like is the price of gas has doubled across this time period. And it has. It did. Between 1982 and 2006, the price of a gallon of gasoline doubled in nominal terms. And the question we would want to know is, in real terms, once we convert into constant dollars, what happened to the price of a gallon of gasoline? So what I'd like you to do is take a moment, and I'm going to fill in actually two more pieces here. To see if you can do this, what I'd like you to do is, I will again stop the video here in a moment, and I would like you to convert the price of a gallon of gasoline here. Convert all of those gallons into 2006 prices, all of those gallons into into 2006 dollars, all of those prices of a gallon of gas into 1982 dollars, and all of those gallons of gas into $1963. And that'll tell us if you really understand how this formula works. I'll come back here in a moment with some of the calculations that I've done, and hopefully we can all agree and we're all on the same page.